Today's lesson is about solving equations with variables on both sides. Now, whenever we start solving equations with variables on both sides, we have to combine our like terms. And what I like to do is draw a line down by equal sign, and then that helps me keep everything separate. And so if you'll look at this problem, we have 15 minus 2x equals negative 7x. Our like terms are these variable terms that have the x's in them, so we need to combine those together. I'm going to move this negative 2x over across my equal sign. Anytime I cross my equal sign, I have to do the opposite operation, and so since this is a minus 2x or negative 2x, the inverse of that is plus 2x. So I'm going to add 2x to both sides. Negative 2x plus 2x cancels, and so all I'm left with is the 15, which I'm going to bring down. I'm going to bring down my equal sign, and because these both have the variable of x, I can combine them. And negative 7x plus 2x is negative 5x. Now that we have everything combined that we possibly can, we need to solve for x or get x by itself or isolate x. Now, what is with x right now is this multiplying by negative 5. The inverse of multiplying by negative 5 is dividing by negative 5. So we are going to divide both sides of the equal sign by negative 5, because remember we have to keep it balanced. What we do to one side, we do to the other. Negative 5 divided by negative 5 is 1. So we have 1x left on this side, and 15 divided by negative 5 is negative 3. Our next example is basically the same thing, except we are going to add the distributive property in. So I'm still going to go ahead and draw my line down my equal sign, keep everything separate. You always have to distribute first. And so anytime you have something multiplied outside of parentheses, you've got to multiply it by everything inside the parentheses. So this is negative 2 times x, which is negative 2x. I'm going to bring my subtraction sign down, and I'm going to say negative 2 times 5, which is negative 10. I'm going to bring my equal sign down. That's the reason that we draw our line. I have another distributive property. 6 times 2 is 12. Bring my minus sign down, and I have 6 times 1/2. Remember, when you're multiplying by the fraction 1/2, that's just like dividing by 2. So this is 6 divided by 2, which is 3, and we keep our x. Now we're going to clean up just a little bit. You never want to have minus a negative. Remember, we can change the minus to a plus, change the sign of next, make that a positive 10. It makes it a little bit easier to deal with. Now we're still going to combine our like terms. We have two variable terms here. We have this negative 2x and this negative 3x that we can combine together. It doesn't matter which one you want to move. I'm going to move this negative 3x by adding 3x to both sides of the equal sign. Negative 3x plus 3x kind of cancels out. It goes to 0, and so we're left with just the 12. So we bring our 12 down, and we bring our equal sign down. Negative 2x plus 3x is 1x. So we just bring that x down. We bring our plus sign down, and we still have this positive 10. Now we're still going to combine our like terms. I still have this positive 10 and this 12 that I can combine together. I'm also trying to isolate this x, get this x by itself, because I want to know what it equals. So I need to get rid of this positive 10, or not get rid of it, but move it to the other side. So I'm going to do the inverse of add 10 or positive 10, which is minus 10. And I have to do that on both sides of my equal sign. And 10 minus 10 is 0, and so that leaves me with an x. I bring my equal sign down, and 12 minus 10 is 2. Here's something that you can try by yourself. Go ahead and pause the video now. Try to work them out. Whenever you're done, unpause the video, and we will reveal the answers. Okay, now that you've worked these problems out, they should look something like this. I know it's a little bit different just seeing the answers rather than seeing me work them out. But on this one, you can see that we combine the x's together by subtracting 2x off both sides. Then we ended up with negative 5x equals 19. We had to get rid of this times negative 5 by dividing by negative 5 on both sides. Remember, whenever we have this improper fraction, unless it's going to work out as a whole number, you leave it the improper fraction. So that's why we're left with negative 19/5. Same kind of situation on this one, but the only thing different is instead of just having two variable terms and one constant, we have two variable terms and two constants. I chose to move my 2.5y over to the right, so I subtracted 2.5y to both sides. That left me with 6 equals 2y minus 1. I moved my minus 1 over by adding 1 to both sides, which left me with 7 equals 2y. To get that y by itself, I had to divide both sides by 2, and 7/2 does not work out evenly, so I just left it as 7/2. On number 3, we had the distributive property, so I had to do 6 times 4, which is 24, bring my minus sign down, 6 times z, which is 6z, equals my 2x, and we're left with the same situation that we had on number 1. We're combining these variable terms together, and the opposite of minus 6x is plus 6x, so I did that on both sides of my equal sign to keep it evened out, balanced out. 6z, excuse me, not x, is negative 60 plus 6z goes to 0, which leaves us with 24, equals 2z plus 6z is 8z. To get rid of this times 8, we do the inverse, which is dividing by 8. The improper fraction 24 over 8 actually does work out evenly to 3, so you could just simplify that to 3. Now the equations that we've been dealing with so far all had one solution, which means, x equals some number or c equals some number. Sometimes equations don't have one solution. Sometimes they have no solution, or they have infinitely many solutions. Anytime you work out an equation and you end up with a statement that is not true, for example, they have 0 equals 2. 0 is not equal to 2. That is not a true statement. Those equations have no solution. So anything that's not true, 5 equals negative 3, that's not true, so that would be no solution. Another option is statements that are always true. For example, x equals x. That is always true. And so the answer to that would be infinitely many solutions. Another example is if you have something like 4 equals 4. That is a true statement. So our answer is infinitely many solutions. And so if it's no solution, we just put the 0 with a slash through it. Infinitely many solutions, we put the little infinity sign. So let's look at some examples that go with that. So as you can see, example 3 is solving equations with no solution. So what we're going to do is just like on the other problems, because remember, when you're working these problems out, you're not going to know beforehand whether it's one solution, no solution, or infinitely many solutions. So we put our line down, our equal sign, and we start combining like terms. I always start with combining my variable terms first. So I'm going to move this negative 4x across my equal sign to combine it with this negative 4x over here. Because I'm crossing the equal sign, I have to do the inverse operation, which is add 4x. So I'm going to do that on both sides. Negative 4x plus 4x is 0, and that leaves me with a 3. I'm going to bring my equal sign down. Negative 4x plus 4x is also 0, or cancels out, however you want to say it, and that leaves me with negative 7. Now we know that 3 is not equal to negative 7. That is not a true statement, so our answer would be no solution. Our next example, example 4, solving equations with infinitely many solutions. We're going to do the same thing. We're going to draw our line down our equal sign. And the first thing that we notice whenever we look at this problem is this distributive property right here. So we know we have to distribute first. So we have 4 times 3/2. So we're going to have to come over and do some little scratch work. We have 4 times 3/2. Remember, we're going to multiply our numerator straight across. 4 times 3 is 12. Multiply our denominator straight across. 1 times 2 is 2. This improper fraction actually works out. 12 divided by 2 is 6. So we know that 4 times 2/3 x is 6x. Plus, we still have to finish distributing. 4 times 1 is 4. We bring our equal sign down, and we haven't done anything with this side. There's no distributing to do or anything like that, so we are left with 6x plus 4. So we're going to go ahead and combine our variable terms. I'm going to move this 6x over. It doesn't matter. You may choose to move this 6x over. It's going to work out with the same answer in the end. Because I'm crossing my equal sign, crossing my line here, I have to do the inverse, which the inverse of this positive 6x is a negative 6x or minus 6x, either way you want to think about it. 6x minus 6x is 0, so those cancel each other out, and we're left with a 4. Equals 6x minus 6x is also 0 on this side, and we're left with a positive 4. And 4 is equal to 4. That is a true statement, so our answer is infinitely many solutions. So here's a couple for you to try. Go ahead and pause the video and try these, and whenever you're ready, then you can pick back up and get your answers. Okay, so if we'll look at these, we can move these boxes out of the way here. On our first one, you can see we combined our variable terms, which they both went to 0 and left us with 1 equals negative 1, which we know is not a true statement, so that's why our answer is no solution. On the next one, we had that distributive property again. 1/2 multiplied by 6, remember, is the same thing as dividing by 2, so that's where that 3t came from. 1/2 of 4 is 2. When we combine these variable terms, we ended up with negative 2 equals negative 2, which we know is a true statement. Those are actually equal to each other. So our answer is infinitely many solutions. Now make sure whenever you're working these problems that you don't leave your final answer as 1 equals negative 1. Make sure you put no solution as your final answer. Same thing on this one. Even though negative 2 equals negative 2 is a true statement, you want to go ahead and put your final answer as infinitely many solutions. Here's a couple of more if you want to pause the video and try these. Okay, if you want to check your answers, these are a little bit more involved just because you have distributive property on both sides, but you follow the same steps every time. Distributive property, combine your like terms, and solve for your variable. Get your x or your v or your b or whatever variable you have by itself. Okay, another type of problem is we have a word problem where we have to write our own equation and then solve it. So if we look at this, they're talking about two different gyms here. We have Green's Gym charges a one-time fee of $50 plus $30 per session for a personal trainer. And then this new fitness center charges a yearly fee of $250 plus $10 for each session with a personal trainer. For how many sessions is the cost of the two plans the same? So whenever it means this, when they're talking about the same, that means equal to each other. When are these two plans going to be equal? So we can write two expressions and set them equal to each other. So this Green's Gym, they charge $50 plus $30 per session. And remember how we've talked about per means multiply. Now we don't know how many sessions, so that's our variable. That's what's going to change, is how many sessions are we going here. So we're going to make this $30 per session. because per means multiply and sessions is what we don't know. So I'm letting X equal my number of sessions. And we want to know, when is that going to be equal to this other gym that charges $250 plus $10 per session? And after you write this equation, the easy part now is solving it. Combine your variable terms. We want to combine 30x and 10x. I'm going to move the 10x over since it's smaller. That way I know I won't end up with a negative. 10x minus 10x is 0, and so I'm left with 250. 30x minus 10x is 20x, and I bring down my plus 50. Now I'm still trying to isolate this variable. I have these constant terms that I can combine together. I'm going to move this 50, and since I'm crossing the equal sign, I have to do the inverse, which is minus 50. 50 minus 50 is 0, and so that leaves me with 20x equals 250 minus 50 is 200. Still trying to get x by itself. The inverse of times 20 is divided by 20. 20 divided by 20 is 1, and so that's how I get my x all by itself. And 200 divided by 20 is 10. Now, if you'll remember that x actually stood for the number of sessions. Excuse me, I'm writing with my active slate, and it's kind of hard to write on it sometimes. X meant the number of sessions. The question they were asking us was, for how many sessions is the cost of the two plans the same? Well, if X equals 10, then that means 10 sessions. That means it doesn't matter which gym you go to. If you go to 10 sessions with this personal trainer, each gym is going to end up being the same. Okay, let's work one more like this, and I think we'll be done. Easy Car Rental charges $40 a day plus 25 cents per mile, and Ace Rent-A-Car charges $25 a day plus 45 cents per mile. And we want to know what number of miles results in the same cost for one day. So remember, the same cost means when are these going to be equal to each other? So Easy Car Rental charges $40 a day plus 25 cents per mile. And we want to know, when is that going to be equal to Ace, who charges $25 a day, but then they charge 45 cents per mile. So we're going to go ahead and draw our line down our equal sign. And let's combine these variable terms. Let's move the 0.25 or the 2500 since it's smaller. We're crossing the equal sign, so we have to do the inverse, which is subtract 0.25m off both sides. 0.25m minus 0.25m is 0, and so that leaves us with 40 equals, we've still got our 25, we haven't done anything with that. 0.45m minus 0.25, remember 5 minus 5 is 0, 4 minus 2 is 2, so we're left with just 0.2m. We got to bring our plus sign down in between it, we don't want to forget that. Now to get this m by itself, we need to move this 25, and so we're going to cross the equal sign with it, and we're going to do the opposite of positive 25, which is minus 25. 25 minus 25 is 0, and so that leaves us with 0.2m equals, we've got 40 minus 25. You can do the long borrowing, or you can do some mental math. Do 40 minus 20 is 20. 20 minus 5 is 15. Either way, it's going to work out the same way. To get the m by itself, they're multiplying by 0.2, so we're going to divide by 0.2. And that's going to get our m by itself. 0.2 divided by 0.2 is 1m. Now we have to figure out what 15 divided by 0.2 is, because we do not want to leave this decimal in this fraction. So we're going to come over here and do some scratch work just in case you've forgotten how to divide decimals. Remember, the number on the outside, you have to move the decimal all the way to the right. However many times, say we move this decimal one time, I have to move this decimal the same amount of times. So I'm going to move this here, actually add a 0 in, and make this 150 divided by 2. Go ahead and bring that decimal straight up into your answer so you don't forget it. Now we're just going to divide regular. 2 goes into 15 7 times. 7 times 2 is 14. 15 minus 14 is 1. We're going to bring our 0 down. And 2 goes into 10 5 times, which goes out evenly. So that means our answer is 75. So 75 equals M. Remember, M stood for our miles. And so they want to know what number of miles results in the same cost. Well, it would be 75 miles. So if you drove either one of these cars 75 miles, then it would be the same cost. And so that is our lesson on solving equations with variables on both sides.